Hi folks, welcome back to the channel. So this is just a quick video, just a run through a recent upgrade that I made to my setup and share with the Astro community and to everyone else. So here I have the original pier that I installed in my backyard. So it's set on a concrete base, and that base is about 500 mil by 500 mil and then 700 millimeters deep. I've got some M16 rods, and then effectively the concrete was set. The pier was installed on top of those rods and then bolted down with some nuts, and effectively that provided me a stable platform to use my telescope. A bit of a fatal flaw here, because the pier, the concrete base, was built level with the ground, and therefore every time it rained, then effectively the whole pier base was flooded with water, and that ended up not being good in terms of rust. So I needed to do something. I didn't quite know what to do or how to do it, but I knew I needed to do something. This next picture just sort of depicts an encasing that I built, and that was to help sort of rain water and help that rainwater run down, but equally used it to store sort of the electrics that help run the telescope rig. It served for a while, served for a purpose, but again, not perfect, so we needed to do something. So after noticing quite a bit of rust, I then removed the pier, the old pier, inspected the base. The base itself was fine because it's concrete and very strong, but obviously we can see there's a lot of rust. Even the bolts, the original bolts that were nice and sort of chrome finish, are now completely rusted. So again, just reinforcing the fact that something needed to be done. So I consulted dear friend ChatGPT, and I'll run you through it. Originally, I thought about using either a sonotube, 250 millimeters in diameter, or an aluminium ducting pipe, again sort of 260 millimeters in diameter, and then filling that with concrete and having it placed on top of the existing base, and hopefully strengthening the pier to a full concrete pier, fully accepting obviously there's no more flexibility, you can't easily move it around, but I guess with the earlier work that I'd done putting the base there, I was kind of already committed. So I explored different options with ChatGPT, talked about the different strength that I wanted the concrete to be, and kind of settled on sort of a 3-to-1 mix, so 1 part cement and 3 part ballast, which is a mix of sand and gravel. And I have a 3D printer, so again sort of consulted ChatGPT on what I could do from a 3D printing perspective. Sonotubes are very common in America, not so common I think in the UK. But I wanted something quite easy that I could place over the existing M16 rods that I had, but equally strengthen a bit more. So ChatGPT was very helpful, gave me some design ideas, also talked about sort of the strength of the 3D prints themselves and how I should go about doing the project. And we'll run through that now. Okay, so this is one of the elements that I printed, and as you can see, I've got 3 M16 rods, so I drilled 3 additional holes, 10 centimeters deep or 100 millimeters deep, filled that with sealant, and then inserted the rods just to add extra strength. And also, as you can notice, there's a mark in the middle, so kind of marked north to south, just to make sure when I place the mount in its final position, I wasn't too far from the polar axis. So I think I'd left the original rods, which were about 300 millimeters apart, and effectively built around that, and thought, well, actually 7 bolts in total will provide that extra stability and strength, acting as rebar for the new core. So that's where we are. Okay, and here we can see I also printed sort of a template for the mount adapter, just to make sure it wasn't, the final product wasn't misaligned. And now we can start to see the pour going in. So I kind of had slot-in sections. So one part of my print was up to 250 millimeters or 25 centimeters. And it was done in 3 parts. So all in all, the total height of the concrete build was 750 millimeters. And the M16 rods themselves were 1 meter. And now we're starting to see it taking shape. At this point, it had dried for a while. Started putting electric boxes, placing the wiring back in, slowly taking shape. Let it dry a bit more. At this point, I think it had dried for about 2.5 weeks. Let another week subside, and then placed the mount on the pier. So this is the 10 micron GM1000. Okay, and then waited a bit longer, and then placed the telescope on top. So now it's fully loaded. A lot of weight on that, but it has provided a very, very stable platform for me to perform my astrophotography. And these are all the accessories behind the Sharpstar SCA 260. So it's got a focal length of 1300, a focal ratio of 5, and this is the final result that I got from first light. I hope you enjoy.